Hello, my name is Claire Green.
Hello, my name is Brennan Brower.
Hi, my name's Alondra Fregoso.
And this is our presentation on global average temperature. And this is our table of contents, which is basically just an overview of what we're going to be talking about in this presentation. So, for calculating global temperatures, scientists use anomalies to calculate global average temperatures, and this is both on the land and in the ocean. And warming is generally greater over the land than is in the water. And what are anomalies? That's basically the difference between actual temperatures and average temperatures over 30-year periods. And we use this to calculate how those temperatures are changing over time. NASA's temperature analysis incorporates surface temperatures from more than 20,000 weather stations. And then as far as the ocean goes, we use ship and buoy-based observations of sea surface temperatures, and then also temperature measurements from Antarctic research stations. And all of this data gets incorporated into one global average temperature. And there are 5 major data sets that actually calculate the global temperatures. So if you look at this graph right here, you can see that there are 5 groups. The Met Office Hadley Center, the NOAA National Climatic Data Center, the Berkeley Earth, Cotten and Way, and then NASA GISS. So all of these groups are measuring the data. And as you can see, it starts at 1880 and goes up until 2020. And this is a measure of our global average temperature anomaly. So it starts in the negative and it ends in the positive. What that means is if you have a negative anomaly, it's going to be cooler than the actual average temperature. And then if it's a positive anomaly, it's warmer than the actual average temperature. And so if you can see, between 1940 and 1960, it's about 0, which is basically the temperatures that were being measured were about the average temperature. It goes close to it. And then from then on, there's a general increase, meaning that it was warmer than the average temperature. And so you can see that there's a general trend rising, indicating that the Earth is warming. And then there's variations in this data due to limitations in measurement. For example, there's measurement errors. Data coverage plays a role because more than 70% of the world is made up of oceans, and that makes it pretty difficult to fully collect data from all areas of the world. And then also instrumentation changes. As new technology develops, we get new forms of instruments that are used to calculate the temperature, and all of that factors into these limitations. And as far as data coverage goes, groups like NASA cover 99% of the globe, and then groups like JMA only cover 85%. So that's a pretty drastic difference in terms of what is being calculated. If you look at these two maps, if you look at the left, we have data from the HAD CRUT3, which is the old version and how we used to calculate global average temperatures. As you can see, the white areas on the map, those are the data gaps. So for whatever reason, those areas were not measured, or there's inadequate data and it just didn't get factored into the global average temperature. And the ones that weren't covered were, well, a lot of it was the polar regions. And so if you think about it, if you don't include like the polar regions, whatever your global average temperature is going to be a lot warmer than it would be if you had included those polar regions. So the data is going to be skewed. If you look on the right, we have the reconstructed data from the Cotten and Way group. And they redid this data and they included all areas, so we don't have as many data gaps. And so that leads to a more accurate average global temperature. And these data gaps, they can lead to issues because, the Earth doesn't warm evenly. Different parts warm faster than the others. The Arctic warms twice as fast as the global average, so if you don't include that, it's really going to skew your data.
Why is global temperature important? Well, calculating the average temperature can help us predict and understand trends in climate change. It also tells us about the energy that circulated the Earth. This energy is responsible for heating the Earth and atmosphere, and it has a huge role in photosynthesis, the water cycle, ocean currents, and weather. There has been a rise in temperature throughout the years, and it's been increasing by a lot due to fossil fuel consumptions and human industrialization. And this is very important because if there's a rise in temperature, this means that ice sheets are melting and sea levels are rising, which all affect plants and animals and the habitats of these animals. And some animals that are being affected right now are sea turtles, crocodiles, and alligators, because temperature determines the sex of these animals, and females usually hatch at a much higher temperature. So if there's a high temperature and only females are being produced, then it really stops the reproductive cycle they have going on, and it could lead to extinction, which is a big issue. Now, how does this all relate to something we've learned this year so far? It relates to thermochemistry, and I will be using the heating curve to show this relation. So, on the heating curve, you can see how solids can turn into liquids, and liquids can turn into gas, and if we flip it over, gas can turn into liquids, and liquids can turn into solids, right? So, anyway, this all happens because the temperature is increasing and more energy is being added, and if the temperature is to increase, then the phase must stay the same, and if the phase is changing, the temperature needs to be constant. Now, connecting the dots with the other graph I have for average global temperature, you can see there's obviously a rise in temperature, that heat is being absorbed and all of that. There's going to be a phase change. Like I said, the solid to liquid, more heat, so it's melting the ice sheets, for example, which is a really big issue. And because the temperature is still increasing, that liquid that was melting is going to turn into water vapor, which is a gas, and it is going to create droughts and a bunch of heating waves. And it is very important to keep tracking all of this and how if the temperatures are increasing or not, because it affects the ecosystem, and it's just very good to know what's happening around us.
So, what still needs to be determined about determining temperature? Well, for one, we still need to determine whether or not it is possible to lessen our measurement errors. As new technology arrives, we need to find out whether or not it is possible to create new instruments using these technologies that might help us solve that problem by giving us more accurate measurements. As well as this, we need to determine how and when to expand our data collection coverage. For instance, we could find out whether or not it would be possible to collect data from space or other locations. Lastly, as data gaps are a prevalent issue, we need to know whether or not it is possible to use data that we get from nearby regions, as well as data patterns from a specific location, to try to fill in any gaps we might find in the data we collect from there, or whether that would be too inaccurate. So, why should we fund this research? Well, firstly, having funds in this field would allow us to fine-tune our calculations, and this would allow us to take more accurate values from our data, and we can use this accurate data in other fields of research, say like climate change research, to allow us to get more accurate results in that field. On top of this, we can use these better values to predict and prepare for future temperature changes, and with these predictions we can also prepare for the problems that might come from these temperatures. For example, if we could predict a wave of very cold temperatures in an area, we'd be able to stock up with supplies and other necessities before it happened. Lastly, tying into these problems, a lot of our needs are affected by climate change, which is caused by temperature change. Things like hot weather can dry up our lakes and put us into droughts, or extreme cold can kill off crops and put us into famines. Being able to tell the temperature in the future would help us fight climate change by taking the steps beforehand to counter it.
This is the end of our presentation. Thank you so much for listening.